look, I'm just going to give you guys a really high level on E3 just to provide context, and then we can dive into this. And I would love your guys' thoughts on the industry and what you guys are seeing and where you guys see the industry moving from a lithium production perspective. Obviously, this is what I eat, live, sleep, and breathe. So I can get too much into the details, but also skip things that I take for granted. So just stop me at any time. Let's just have a conversation. So E3 is a company based in Calgary, Alberta. We have a project just north of town, and we're developing a lithium process to extract lithium from brines. Our goal is to build a portfolio of lithium production in Alberta. And we just put out a pre-feasibility study, which gives the fundamentals of the project. So I thought I could start with this because it sets the tone. So to give you guys an idea of the cost of capital required to build out the lithium industry, Benchmark Minerals is estimating $60 billion of capital to come into the industry to build out enough production to meet the demand for lithium. Because most lithium today needs to be brought on from new supply because we don't have enough of a market for it. 10 years ago, 50,000 tons of lithium was produced every year. By the end of the decade, they're talking 2 to 3 million tons of lithium required to meet the demand for batteries. So that ramp up in 15 years is something that the world doesn't normally build for mineral projects because the average success rate of a mineral project is about 2%. So if you found a lithium deposit somewhere and you hammer it on a rock and you tested it had lithium in it, to take it from there to a mine that's operating is an average of 20 years and a success rate of 2%. So you're talking about scaling mineral production at a rate that never normally gets scaled at the rate that it needs to meet the demand. And it is just a completely different landscape than, say, a battery facility, because with battery, like it's an engineering challenge. You build a facility, you don't have the same exploration and development that minerals and mining has to go through to get the lithium to the project to a place where you have the confidence to produce lithium commercially. And this project to produce 32,000 tons of lithium a year is going to cost $2.4 billion US to build. So then the other question comes, where do you get the capital to build out a project like this? And the industry is answering that question with government support. They're answering that question with OEMs and other companies investing in projects. LG's invested in some, but you look at guys like GM, they put $650 million into a project called Thacker Pass in Nevada. That's where the industry is going to get the capital to build this project. At least that's what we're seeing. But fundamentally, what's important on all levels in this industry is that the electric car is a much more sustainable, even if you're powering on natural gas. The electric car uses less carbon per kilometer than an ICE or equivalent. The challenge is the battery, and where the carbon intensity comes into these cars is generally the battery, and the mining it requires to produce all the minerals to make the battery. And so sustainability on the mining side becomes fundamental in the conversations you're having, especially with the OEMs, especially the European ones who are, I'm probably guys well familiar with the battery passport that's coming in and all of the implications that's going to have to the sustainability metrics. And so how we get ranked and how we get judged is largely on the price. Obviously, number one, dollars obviously is the most important factor, but second is the sustainability. What is the impact for carbon? What is the impact from land? What is the impact from water use? Which are the three big impacts from mining. When you look at it from how you can't eliminate the impact of extraction of minerals, but you can minimize it. And the three metrics are those three. So just to step into, first of all, how the world currently gets their lithium. Right now, this is changing pretty rapidly, but nearly 100% of lithium comes from one of two sources: hard rock mining or solar evaporation ponds. And I'm sure you guys are familiar with both of these. Currently, 50% of lithium molecules in the world are coming out of Australian hard rock mining. Most of those are being processed in China. That is changing. Pilbara Minerals and POSCO have a joint venture where they're now doing the conversion in South Korea. So we're starting to see those conversion facilities get built elsewhere outside China. But the majority of the processing for batteries is from the Australian hard rock sources is through China. Obviously, there's a big geopolitical concern about that, and we get pulled into that being a domestic supply. I think it'd be very hard for us to sell our lithium into China, given the current geopolitical headwinds. But there's a big enough market locally, obviously, for that. Solar evaporation ponds, there's one in the United States. The majority are in the Lithium Triangle in South America. There's some in China as well, in the sort of closer to Mongolia. So that's where we get our lithium from today. The new opportunity to make lithium, and it's a brine source, is what E3 has been developing and others, is direct lithium extraction. And it's a garbage can term that a lot of people use, especially companies trying to sell their wares. A lithium company trying to sell what it's going to do, they use the term direct lithium extraction. To use it properly, it needs to be the primary extraction, the thing that removes the lithium from the brine in the first instance. That's what I would refer to as direct lithium extraction. The ones that are being commercialized today are aluminate-based sorbents in a solid liquid separation processing. So for the non-process engineers, basically you take a bead that is about 1 millimeter in size that is made out of aluminum, and you mix it with water, and the lithium sticks to that bead. And then you wash that. Once eventually you fill up all of your beads in a big tank, you fill them all up with lithium, and then you wash that lithium off, and you make a lithium chloride. And that lithium chloride is the precursor to most of the lithium products in the world today. So you can refine it into something that's battery grade. You can make metal, you can make hydroxide, you can make carbonate. And that processing methodology is fairly new. There are only 2 companies commercializing it today that have actual operations. So Sun Resin, which is a Chinese company, has production in China, and it's happening. They're probably making 80 or 90,000 tons a year of it using the method. The challenge is we don't necessarily know if it's economic or state supported. So that veil of not understanding how valuable that actually is from a commercial basis is hard to therefore validate it outside the Chinese ecosystem. So the only opportunity that we've seen for this operating outside China today is Eramet, and they're commissioning a direct extraction facility in Argentina right now, and is the first major commercial facility for direct extraction being commercialized. So what that all is saying is that this is a fairly new method. And in Alberta, we are still looking to build a facility, so we haven't yet turned this thing on. But when you look at it from a sustainability aspect, and I'll get into this in a bit more detail, it definitely stands out. And so when you look at it from Alberta's perspective, and why Alberta is such a great place for lithium, is that we operate DLE like you operate oil and gas. So Mark, you're from Texas. How you drill a well, you put it in a pipe, you bring all of that liquid to a central facility where you extract the commodity. That's how oil and gas operates. And we're in Alberta, which is often called the Texas of Canada. It's the oil and gas center of Canada. And we have a huge oil and gas resource here. This aquifer that we're producing out of used to be an oil aquifer, had very little oil in it relative to water. They've produced all the oil off. Now it's just full of water, and the lithium's dissolved in the water. So we can use the same reservoir extraction methodologies that oil and gas uses to get the fluids out of the aquifer, and then we put it through the DLE technology to make the lithium chloride, and then the water goes back down. And so from an infrastructure perspective, fundamental to the ability to do that. And this is what this looks like. This is half of our footprint. So when you look at this compared to like a hard rock mine or a salar, this is our facility. This is about 1.5 kilometers by about 700 meters. So this is the central processing facility. The only other impact this project has is the well pads, and there's 38 of them that are about 100 by 100 meters. And so surface impact wise, there's nothing that competes to direct lithium extraction. And that's why these are so important for the world's source of lithium. When you look at it from a sustainability, and this is where I want to like pose the question to you guys in a couple slides, is how conscious is the industry, from your opinion? This is the question I'm going to ask you guys, on the social, on the ESG, on the environmental, on sustainability. What is that social consciousness that people buying cars, therefore the OEMs, the governments, what is that requirement for environmental consciousness? So from a direct lithium extraction, the process that E3 has developed uses zero water and puts zero water back in the environment. So there's no impact from a water perspective. We don't use fresh water from the environment. We don't put water back into the freshwater part of the environment. We also are going to reduce our carbon emissions down to something that's industry leading, about 1.9 tons per ton of CO2. To give you an idea, a solar is about 5 and a hard rock mine is about 15 tons of CO2 per ton of lithium. And then land use. Obviously a big open pit mine or a big evaporation pond relative to something that's about 1.4 by 700 meters, this size, and then double that for the well pads. This is what a well pad looks like. This is our well. Alberta is a great place for permitting, which is one of the biggest risks. And just our project looking at turning it on in the end of 2027. So that's enough of what E3. Maybe we can talk about the North American context, because I'm in North America and a lot of this is California based. So I thought we could stick to just North America. The top graph is the global supply demand fundamentals. And with the current, this is Benchmark Minerals Intelligence. So this is just borrowed from them. When you look at this, the top graph here, end of this decade, it looks like we go into a supply deficit. Really what this means is this is when all the battery factories in North America turn on, or let's say ex-China, European and North American. This is when we all turn those battery plants on. LG, obviously you guys big component to that. And the plans that LG has, among others. And then when you look at this from the North American context, we're already in deficit. So that means that we're importing. And it looks like from this graph, North America will remain a net importer of lithium for its batteries. And this situation is nothing relative to Europe that has less opportunity to bring supply into the market. So the reality is that from the non-Chinese perspective and the geopolitical headwinds of how much Chinese lithium can come into the North American and European supply chain is a big question right now. And I don't think there's any clear answer. We don't know who's going to get elected in November. We don't know what's going to happen to IRA. We don't know if we're going to get what Trump has promised, 100% tariffs. Like, we don't know those questions. We do know that the European Union is starting to back off of their restrictions a little bit because they're too onerous, restricting the Chinese lithium because there is no other opportunities today. So what does that mean? What does that mean for the context of where we're getting our lithium from and how important are new sources? And then I thought that through this in because I am Canadian, and I thought I'd look at the Canadian supply demand. So this is the same graph I had in the previous slide. This is the North American context. This is the Canadian supply chain, 250,000 tons a year. Once these 4 companies, this is just 4 that have committed, it's about 250,000 tons if they reach the capacity that they've promised in their public announcement. So this is purely if these guys build these facilities as they've outlined in terms of capacity, it consumes about 250,000 tons of LHM a year. Canada currently produces 0. North America currently produces for molecules within North America 4,000 tons. And the Canadian deficit is 250,000 tons. So even the Canadian market is going to be constrained for lithium. So this is really, and I just sort of rushed through that, but I really want to have time to chat because I would love your guys' perspectives. Like, where are we getting the lithium from, if not China? And if China, what does that mean for the supply chain? And then how much do you think the social consciousness of the sustainability of your lithium is going to play a factor in what people are asking for from their products. I think you're muted, Raul. Is it Raul? I can't hear you, unfortunately. Can you guys? No.
It would be interesting to see how other competing elemental technologies will impact the use of this lithium.
Yeah, that's a good point. I definitely think that there's a place for sodium ion in the global supply chain. I'm not sure how much it's going to compete with the electric vehicle in the electric vehicle market. I was talking. Was somebody here working with lithium metal? I know I was talking to a lady who did her PhD in lithium metal batteries, and how much that's going to play an important factor in the future, given the energy density potential, if they can figure out the challenges, of course.
So, Chris, hopefully you can hear me now.
Yeah.
Okay, sorry about that. It's just too many devices connected to my laptop. But no, I was going to say that I came to the industry from the automotive, but then came into batteries, and then I spent some time in renewables. And I think one of the problems that this whole industry has is that everyone looks at it very narrowly, because the guys that make battery cells look at making battery cells. The guys that make vehicles look at it just vehicles, and then yes, they have to purchase batteries. So I think there's a lot of opportunities to cut across the value chain and figure out, okay, given that we all are talking about lithium right now, how are we going to get lithium? So so I see a lot of opportunities just in people that are up and down the value chain, having conversations on what do we do. This is not going to solve everything, but one of the best things, in my opinion, that the IRA has is that they have a requirement for recycled battery material to be put back into the vehicles. So, and this is probably controversial, but if we would allow Chinese vehicles to come in, the batteries in those vehicles, we would have access to it. And the more we recycle, the less we'll need to dig holes in the ground or pump water out of the whatever. So there's some benefits in allowing Chinese vehicles into the European market, into the US market. Now, is it enough batteries? I doubt it, but it's not zero. So there's definitely some opportunities, but none of them I think are like a silver bullet, because they all require political will, which is probably the most limiting factor right now. Like you said, right, that we don't know what's going to happen with U.S. elections, etc.
Yeah. I think I see this industry in its entirety, as you're saying, as very immature, right? Like, how we operate today is a relic to the fact that, lithium is produced before the battery really became something of high demand. One hard rock mine in the entire world, Greenbushes in Australia, and a byproduct from potash, effectively, right? And then in the late 2010s, companies like Albemarle and this is the non-Chinese companies started to focus production in the salars on lithium because of the value. The Australians do what they do best, which is mine hard rock and turn on a bunch of mines and the ramp up. But I think that vertical integration in terms of how you make batteries and integrating into the source of lithium is one potential solution to reducing the cost of production, and therefore being able to, for example, we can make a metal directly from our chloride. So we don't have to go through the conversion to carbonate and then remake that and ship it, remake it into liquid, a slurry, and then, make a lithium metal out of it. We can do it directly, but you would never do that in the Atacama, right? So location becomes important. And as we start bringing lithium in places that are already industrialized, like Alberta or Arkansas or some of the other places where you see DLE, you might start to see the ability to vertically integrate might make a lot more sense. And then, where there's a will, there's a way.
Well, and I mean, and that's probably the key of this whole thing is if there's the willingness, because you can look at China and some of the companies that have been more successful is through vertical integration, because there's the appetite from the government to push these kind of structures, versus here, I mean, at least here in the US and maybe also in Canada, and especially this year, people are a little bit they see like the mining, that's the old industry, right? So maybe it gets subsidies, etc. And then they see the EV space as this climate tech. So, it's a little bit like one is more for one party and the other one is more for the other party. So then some of the decisions are not going to be the most efficient, again, in the value chain. Because I mean, like I said, I came from the automotive industry, and automotive is a heavy user. I mean, one of the reasons we're talking about batteries is just because automotive is using so much batteries. So not to say that automotive is at the center of the world, but automotive is pulling all this stuff. But automotive doesn't know how to manage, mines. They don't know how to manage recycling centers. They don't know how to manage these supply chains that come. Well, maybe they can manage a little bit the China, but there's a lot of there's a lot of opportunities, but it almost requires a different frame of mind, where you say, okay, I'm an automaker, but I'm going to be a partner with the guys that do the mining, with the guys that do the refinement, with the guys that do the recycling.
Yeah. Yeah, exactly.
If you guys don't mind if I chime in.
Oh, please.
I worked in the electronic recycling world for about 11 years. And back in 2010, there was an automotive manufacturer called Coda that folded. Here, based in Los Angeles, we have nothing more than lots and lots of cars. I'm sure just like where you all reside as well. But when those EV batteries came in back in 2010, early on, we had to collect them all. All the batteries came in. I think with the developing EV world that's going on, globally, even a hard push here in California, eventually all these auto manufacturers are going to have, people in place to figure out, where these batteries end up, eventually getting brought back to get recycled, like Raul mentioned.
Mm-hmm.
And, I never thought of that in that perspective, where if the U.S. ended up taking in more Chinese vehicles, that, as a result, that's why China cut off, a lot of the recycling efforts here to go towards them. So if the U.S. opens up, over time, there's going to be more material, which eventually, will need to be figured out how to get recycled in the best way. And Canada plays a huge part. I know this because of whom we dealt with, and I think Mexico might even have some part of it too, and also some of the parts of the Midwest, the United States. But yeah, that's what I wanted to add. And also with the folding of companies like Fisker, everybody's heard that EV car company folded. So they're just trying to offload, their and it's all developing too, with all these different models coming out. Yeah.
Yeah, I agree. The recycling question, I think personally that we need 100% recycling of every battery ever made, because the most concentrated source of these minerals are in the battery. So they're therefore the cheapest source of supply. And you're right. If you brought in a bunch of, right now, that most of the lithium in these batteries is coming from China. So the Chinese lithium is what we're recycling and making batteries out of in the end use. But there is a huge time lag. If you take Tesla's, 8 to 10 years, and then you take the second life Powerwall and et cetera, like those batteries are into the marketplace for, I don't know, 15, 20 years. And that's why I think like the EU's may be stepping back on some of their restrictions that because the Americans have put in, and Canada as well, a little bit, like they're more carrot, whereas the Europeans are definitely more stick in their approach to trying to move things forward from a geopolitical standpoint. And both have their pros and cons, but definitely I think there's good cause to think that recycling is going to have a part to play, but it doesn't satisfy the immediate need. And the other thing about there's a comment here about local jobs and all of that, and I just one of the things that we're seeing right now in the world is a global pulling back from China, right? Like it's not just critical minerals, it's not just lithium-ion batteries, it's a lot of different aspects of our daily lives that we're trying to pull back. So that what happens about when you just inherently, we can talk about this, we're trying to make cheaper and cheaper batteries, but if we onshore in North America and Europe, all of that manufacturing, we can't do it as cheap as China can. So it's inflationary because you have to build the capacity, you have to build the factories, and you have to pay higher wages. And all of that means that you're going to pay more, right? So that's the other side of the coin of bringing the manufacturing locally, is that you create inflation. You also create your own industry that creates jobs. And those jobs are local jobs with local expertise. And I think that's a very important thing for North America to do. I think we should have that. That's a personal belief. But the trade-off to that is inflation.
Yeah, Chris, since you're touching on cost, right? We have a debate about why the EV adoption rates have slowed. Part of that, you can say the first wave of early adopters were willing to pay a BEV premium. And between A, moving into mass market, and B, with inflation going up and with interest rates going up, the cost to own a BEV just got a lot more expensive in terms of initial purchase price. So, how that changes over the next decade. You mentioned lithium operations is not a 5-year make the decision now and get output out. So you think over the longer direction of that, automakers are always under tremendous pressure on margin. And also meeting federal fuel economy requirements.
Yeah.
At the end of the day, you can say automakers set price, but at the end of the day, customers choose what to buy and what's affordable to them. So once you start seeing that EV premium drop, right, so you get closer to parity with a conventionally powered car, will customers start looking then to your question about more sustainable sources for what goes into that product? Possibly. Though the first step is to continue to get that EV adoption rates up. And I would say the auto industry right now is, as many industries, even including John Deere and off-road, are focused on affordability of the product.
Yeah. In a lot of ways, like I get Elon Musk's push towards the robotaxi. I think like in the future, driverless cars entirely in cities is going to be the way of the future. There's no reason why humans have to drive cars. But if Tesla was able to build, and they're probably in the best position to do it, a $25,000 car, it would probably eclipse the 3 as the top selling car, because it would just open up this whole market that no one, like other than the Chevy Bolt, whatever it is, nobody's really in that market, and not in the range category that Tesla potentially can offer. So it's interesting.
Yeah, because when we talk about sustainability, at the end of the day, the industry monitors dollar per kilowatt hour. So you're You think in terms of tons, and I'd have to end up translating that to say,
Yeah.
well, get me all the way back to what does that mean in terms of dollar per kilowatt hour for, choice A that has more sustainability and choice B that maybe isn't quite as sustainable. But ideally making that choice the easiest as possible for manufacturers, right? The closer to parity with goodwill. Most big companies like John Deere and Ford are always going to want to do the right thing. They've been in business for over 100 years and want to make good decisions for the environment.
Yeah, and that's a good question. It's like maybe sustainability is an important topic, but maybe the answer to that is when. Like, when do we start caring about sustainability, or when maybe will we pay more? And maybe that day is not today. Like it's a big conversation that we have. It's like we can get our carbon down to an industry leading number, but it's additional capital. So to do the capture out of the power plant. So maybe that's year 3, right? And if a customer came to us and said, we'll sign this agreement with you, blah, 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 but you have to have your carbon down, we can say, no problem. Here's the additional cost to the lithium to do that, because we have to pay that somehow, right? We have to pay for that somehow. So it is an interesting question. I think building future proofing is what we're really talking about, right? Like, can you future proof into a world where all things being equal, sustainability is the first question they get asked, not the second or third.
And Chris, I mean, I'm not answering the question directly, but one thing that I find interesting, I just before I started my own business, I was in industrial automation, and so in the manufacturing of vehicles, the conversation has started around sustainability, but not as sustainability by itself, but how do we create advantage, a competitive advantage through sustainability? So it's basically, how do you better manage your energy usage when you're manufacturing a car? How do you manage your water usage and treatment and whatever during the manufacturing process as a advantage, because it costs less, you use less water, less energy, etc. So it's interesting because and I've been in manufacturing and automotive for a long time, but it's only recently that it's like sustainability pulling in these ideas of margin improvement, lower cost of operations, etc. So it's not yet a standalone, I feel, but I feel like it's pulling stuff along. When are consumers going to worry about that? You're a consumer. When would you start paying more for a electrical vehicle where the batteries were recycled 100% versus brand new?
Yeah, exactly. And right now, people are already struggling to justify the cost as it is, right? So there has to be a step change in a car, that affordability of a car in general, right? To say, yes, I'd pay that now incremental more. Or the other option is that, the lithium sources are the same price, but you are able to offer sustainability because we're implementing technologies that are solving that problem. And I think that's sort of E3's solution. Like our project is a bit capital intensive, but not any more than Thacker Pass's project in Nevada that's just got funded. It's the same price per ton for capital. But we offer, and we're cheaper to operate on a per ton basis, but we offer sustainability. So if all things were being equal, would a company invest in a project that for the same price of lithium would be more sustainable?
I think that's a great point. I guess in the short term, I don't think people will be willing to pay for the premium, or at least the OEMs are not. So I think, just like you mentioned, as long as it's the cost is at par with the conventional ones, then the carbon benefit or ESG benefit will definitely play a role. And I think that's the way that maybe new unconventional lithium companies that are entering the market should play, because that's going to definitely increase or get the traction from the industry. And speaking of recycling, going back to it, because of that price, and also because there are only scrap seems to be only viable source that we can discuss at the moment because there aren't that many end-of-life EV batteries out in the market yet. I think we really do need to work together to create that ecosystem and create a closed loop. And I think the only sort of a model that we can go after would be tolling model, therefore, at the moment. So, which will, I think, should be able to bring the costs down to the market price level, and probably the only viable way of doing it at the moment.
Chris Noah said that well. If you're at price parity, most companies that sustainability message would be great added value, and I think you find a lot of business here coming your way when there's no price premium. I think it gets a little trickier when you try to put a dollar on how much of a premium would a company be willing to pay, and that might be situational. But at parity, I think most companies would look for the best solution for sustainability.
Yeah, and I agree with that.
Yeah, I personally look at more of a how to prove the technology at a commercial scale rather than the premiums on the ESG at the moment. But I'm pretty sure if it goes down to parity, then I think we need to focus on whether it's a scalable technology and how do you prove that with your customers. I think that would be the an area to focus at the moment.
Yeah, and that is true. It's any new technology needs that technology prove out. I think we're out of time. I think the question I would pose to you guys to think about as a takeaway is, and like a great point to end on there, because let's do the thought exercise and assume that DLE is going to become a technology that becomes readily applicable to brines across the world. If you can produce new projects with DLE, and we haven't even started exploring for deep basin brines that have lithium in them. We've only been finding them on the back of oil in Alberta, or geothermal power in California, or oil and bromine in Arkansas, etc. If you actually started looking for lithium brines for the purpose of lithium, and you opened up that exploration and you found more opportunities, would you hard rock mine? Would it be something that would even do? And the answer from our perspective is no. If you could feed the world with direct lithium extraction, all things being equal, technology risk aside, you would lean towards direct lithium extraction. So the question is, where would it come from in 10 years? I think that there's enough DLE projects that could be found to feed our long-term demands for lithium in the grand scheme of things. But you can't forsake the fact that there's currently only one commercial operating project outside China today, and that's Eramet. But everyone obviously is watching them pretty closely. So anyway, I think we have to jump back. Yeah. Thank you very much.